This presentation outlines the threat posed by small vessels operating in the maritime environment and a low-cost option for responding to the small vessel threat. The United States has over 95,000 miles of navigable coastline and more than 350 ports. Waterborne shipping provides 13 million jobs and adds $742 billion to the U.S. economy. A small vessel attack, such as the ones that occurred to the USS Cole and motor vessel Limburg, would be devastating to the U.S. economy. Existing port surveillance systems are overly reliant on the Automatic Identification System, AIS, to monitor vessel movements. Problem is, AIS is only required on larger vessels greater than 300 gross tons, or roughly 100 feet in length. It does not address the small vessel threat. More importantly, AIS is a self-reporting system. Terrorists could simply turn off their equipment to avoid detection. Government efforts to require AIS transponders on all small vessels would place an undue financial burden on small vessel owners, raise privacy concerns of government agencies tracking the private citizens' movements, and greatly increase AIS call volume. Authorities would essentially be looking for the same needle in a much larger haystack. Small Vessel Threat Response, or SVTR, uses existing radar, cameras, and marine sensors to selectively communicate with boaters using digital selective calling, or DSC, features found on virtually all inexpensive VHF radios. The patented SVTR process detects a vessel and determines its approximate geographic location in latitude and longitude. This information is inserted into a digital selective calling sequence in accordance with internationally accepted DSC formatting and transmitted on VHF channel 70. The recipient vessel's radio will ring and automatically tune to an appropriate frequency for a follow-on voice message. Here's a quick demonstration. Once the target vessel's radio has automatically tuned to an appropriate follow-on voice frequency, SVTR transmits the appropriate voice message.
Vessel approaching a docked U.S. Navy warship. You have entered a restricted zone.
In this scenario, a virtual geofence is established around moored Coast Guard cutters. A digital voice message is composed using a microphone or text-to-speech function. A scanning receiver selects a clear channel for the voice transmission, and the entire sequence is encoded into the DSC transmission. Any vessels entering the security zone will receive an automated response. Here's a demonstration of what the vessel operator would see as his boat approached and entered the security zone.
Vessel in the vicinity of moored Coast Guard vessels. You are in a restricted zone. Please move immediately.
Because the SVTR DSC call is selective based on geographic location, it is transparent to all vessels outside of the security zone. As the fishing vessel enters the moving geofence surrounding the tanker, it triggers a SVTR response, its radio will ring, and a warning message will be transmitted. The sailing vessel outside the security zone will not decode the DSC transmission, and nothing will be heard. This geographic selectivity is important in a crowded maritime environment. Another possible SVTR application involves the use of UAVs, or unmanned aerial vehicles, for increased maritime domain awareness. In this simulation, a UAV determines its own position from GPS satellites. Because the UAV's altitude or height is known, as well as the camera look angle, the relative position of the vessel can readily be determined in latitude and longitude. That information is encoded into the DSC transmission, and selective communications are established. For more information, visit